deep learning AI based mechanisms. So that is basically known as smart greenhouse implementations. And then after agricultural drones, Internet of Food is a very important technology right now. Lot of work is going on in this Internet of Food. Which is managing effectively what is produced, what is distributed, and what is consumed about the agricultural products. Now, the smart agriculture life cycle is based on these 4 steps. Number 1, it is observation. Observation means to collect data from farms, and then after perform some diagnostics, means examining and processing the collecting data. That is basically the diagnostic. And then after we have utilizing AI techniques, that is also the part of diagnostic. And then after you have to perform some actions. What is recommended by the AI system based on the data which is collected from the farm or livestock area, that particular recommendation will be followed by the action takers, whatever the decision will be taken by them. So this is only the smart agriculture life cycle that we have. These are few of the problem statements. Similarly, in case of this smart agriculture, that autonomous tractors enabled with the GPS, camera-based surveillance systems like plantation of crop, apply fertilizers, spray pesticides, managing the weeds, requirement of irrigation, prediction of yield, robotic solution for sustainable food for future. These are few of the problem statements on which those who are interested may work for these problem statements. Yes, this was about smart agriculture. It's a very introductory part, that how can we apply AI, blockchain, computer vision, drone based systems, cameras for implementation of the smart agriculture. Now we have this blockchain technology. So for a layman person, how can we understand this blockchain? So here we have one example. Imagine if there is a notebook, and this notebook is shared with 10 friends. And what is happening, if any of them is changing any information, editing or adding or deleting anything into that particular notebook, that must be shared with all of them. This is the condition. So if you have such a realistic thing into technology in terms of database or any of the data processing mechanism, that is known as blockchain. Means everyone must know about the update, about any insertion, deletion, or any kind of thing. That will be processed by informed to everyone. That is basically known as blockchain. And what is the concept map? It is related to transactions. Basically, it is used in banking systems, in financial applications. Blockchain is very much used because whatever the updation or any of the insertion, deletion, whatever you have, that will be there, that no one can delete it. So it is really very important for financial applications, especially in banking sector. This blockchain is very much being used. So components of this blockchain are transactions. You know what are the transactions. Then after cryptography. Cryptography means, do you know what is cryptography? How many of you know cryptography?
Encoding a message. Encoding and decoding.
Encryption and decryption.
Yes. Actually, that is a correct term. Encryption and decryption. And the simple example of encryption is, for example, I am passing a message, CAT, cat. So what will I do? I will convert all these characters with +1. Means C will be converted into D, A will be converted into B, and T will be converted into U. So whatever the message you will get after adding +1, that will be known as, what will be the name? This is known as ciphertext. Ciphertext. And this process is known as encryption. And the key for this particular activity is +1. So the person who knows that -1 will give you the decrypted message. So whenever the person will do -1 into the transmitted message, you will get the original one. So to get the message from ciphertext that is known as decryption. So this encryption, decryption, ciphertext, plaintext, plaintext, ciphertext process is known as encryption. And encryption is a very big science, big technology. A lot of algorithms are developed into this. And all the, on WhatsApp, you see the message that your chats are end-to-end encrypted. What does it mean? It means that your messages are safe. Whatever you are discussing or you are chatting with someone, that is safe. So this is known as encrypted and decrypted message. So similarly, we have encryption and decryption in the blockchain technology also. Consensus means agreement. We all are agree to do this. That process is consensus. And after that, we have distributed ledger, transparency and security, and real world applications. All right. So these are basically known as concept map for blockchain. This is the technical definition that a blockchain is a distributed, decentralized and immutable. Immutable, do you know what is immutable? Bas, simple. You cannot change it. It is immutable. Immutable ledger that records transactions in chronological order across multiple computers. So this is the basic definition for the blockchain. And these are the important characteristics like decentralized, transparent, secure, immutable. And this is one of the real life analogy that is not required here because we already discussed about it. So the reason behind this is, for the development of this blockchain, is that banks, government, universities, payment gateways, they all are using blockchain right now. The reason is that third party was verifying everything in case of the banking financial transactions, but it is not required. Actually, it was very costly, and the information was also transferred to many places. So that's why when banking systems are implementing these blockchain based transaction mechanisms, then there is no requirement of the third party. So that's why there is a huge requirement for the blockchain implementation into banking sector. Now, these are the evolution of blockchain. Initially, it was only related to digital currency, Bitcoin, everyone knows. After that, it came with the programmable contracts, that is known as smart contracts. It is a distributed ledger basically, means whatever the financial transactions are giving for any of the real world application, they all are encoded into this particular smart contract. Then after, beyond finance, now blockchain is being used in healthcare also, in education system also, in supply chain also. Many of the other applications are also using, that is with blockchain 3.0. And now we are running with blockchain 4.0, where we are using these blockchain techniques into artificial intelligence, Internet of Things, cloud computing, big data, digital twins. In all these techniques, we are going to use these blockchain techniques. This is one of the blockchain case study. So in this case study, I am putting here, this is related to business application, blockchain based supply chain management in the food industry. So what is happening, for example, we have a supermarket for organic mangoes, and the claim is that this mango is available with the expiry date of 10 days, but we have 3 days duration from the origin of its place. So what will happen? How can you justify this claim? What is the technology behind this? So only blockchain is there. What will be the mechanism? I am just showing you for this particular case study. Who will be the stakeholders for this particular case study? These are farmer, transport company, warehouse, processing unit, distributor, retailers, and customers. These will be the stakeholders. All right. And how this blockchain will be implemented? On step 1, we have harvest farmer records like farm ID, crop type, harvest date, and location. These will be entered into the blockchain. And then after, we will have transportation, and the transportation will be equipped with IoT sensors. All right. So that is basically having temperature, humidity, vehicle ID, everything will be entered into blockchain with this particular data while transporting that particular product from one place to another place. After that, on your warehouse. On warehouse, the similar information what is required over there, like product quality, quantity, storage conditions, they all will be done over there. So this three kind of data at the origin place, at the place of transportation, at the place of warehouse, everything will be recorded into the blockchain. And then after, obviously there will be a retail store, QR code will be pasted onto the product, and then after the customer will scan this QR product, each and every information about the origin of the product, then after transportation, and then after what was the condition at warehouse, that all information will be available to the customer. So that is basically the implementation of blockchain, which is not possible with any other kind of technology or any other kind of mechanism. All right. So this is just to have reliability of reliable information to customers. Okay, so this was about blockchain. This was one of the case study that was related to blockchain technology. Now I am coming to the last technology, that is IoT, means Internet of Things. Do you know what is thing in Internet of Things? What is thing?
Devices, different devices.
No, this is also a device, but I think this is not connected to internet.
Wi-Fi enabled devices.
Yes, Wi-Fi enabled devices are, yes, any of the device which is using internet or connected to internet by any of the medium. It may be possible that it has a physical internet connection, that is also a thing. So in this Internet of Things, each and everything which is connected to internet, that comes under this Internet of Things. So these are some of the definitions or the important concerns which are related to IoT. Smart watch, smart TV, smart refrigerator, smart car, smart meter, drones, these all which are connected to internet for a certain processing or mechanism, they comes under this Internet of Things. Now, what are the different components with this Internet of Things? We have sensors for collecting the information, like temperature sensor, humidity sensor, motion sensor, pressure sensor. Lot of sensors are available for these kind of devices. And then after actuators. Actuators are action takers actually. And for example, we have fan as an actuator. So what will happen? The temperature will be sensed by a sensor, and the implementation will be done on this fan or of any of the AC unit. So these are the few of the examples of the actuator. Now we have IoT devices which are related to, like all these sensors, microcontrollers, communication modules, softwares, power supply tools, they all comes under the IoT devices. Microcontroller is the brain of IoT device. What should be done by the particular device or a particular processing mechanism, that will be decided by this microcontroller device. These are a few of the communication technologies. It may be Wi-Fi, Bluetooth, Zigbee, LoRaWAN, NB-IoT, and other internet mechanisms may also be there for communicating or for connecting the devices, whatever we have into this particular system. IoT gateway, which connects sensors and devices to the internet. This is one of the other connecting device. And cloud computing is very important because everything is available on cloud. So cloud computing is clouds are very essential component for this particular IoT implementation. Normally we have a 5-layer architecture for Internet of Things, which is a business layer for reports and decision making. Actually it will start from a very basic layer where we have sensors and actuators. Then after, these sensors and actuators will be connected through Wi-Fi, 5G, Bluetooth or LoRaWAN at the network layer. After that we have processing layer with the help of cloud. We have storage, analytics and application of artificial intelligence for any real world problem. Then after we have application layer, means for which purpose you are connecting all these devices to each other. That may be smart home, healthcare, and finally we have business layer, means whatever the data is collected, whatever the outcomes we have, what is processing, and then after what are the outcomes and future directions will be decided based on this executive reporting. So these are the working mechanism of the IoT systems. This is one of the last case study that we have, that how can we implement IoT based smart inventory and warehouse management system scenario. So this will help in implementing this particular warehouse system. Now I am coming to that particular mechanism or the step-by-step plan for this IoT case study.